So what we're addressing here is how Azure could be utilized in this course and what is a relevant course project or laboratory would look like that encompass 2 or more Azure tools. So first things first, Microsoft Azure could be used in this course as an additional avenue to explore health information technology through assignments that are designed to provide hand-on experience with the Azure API for FHIR. So the Azure API for FHIR enables rapid exchange of data through fast healthcare interoperability resources, or FHIR, managed by a platform as a service offering in the cloud. It makes it easier for anyone working with health data to ingest, manage, and persist protected health information in the cloud. The Azure API for FHIR complies with the FHIR standard, is managed by a highly skilled team that would enable cloud-based solutions, and this would open the possibility of using the Internet of Medical Things in this course, and allow patients to own their data and know how it's being stored and accessed. Although lightly touched upon in this laboratory, the Azure API for FHIR could be implemented to create and deploy a FHIR service for health data solutions. With the use of the Azure API, students would be able to grow upon their use and knowledge of the FHIR technology and standards. This would include, but is not limited to, the deployment of a Smart and FHIR EHR launch with the Azure API, as discussed here. We will come back to this later on in the tutorial. So an interesting lab would encompass 2 or more Azure tools and would be implementing a Smart and FHIR application through Azure for mobile applications. But before going into the project details, let's address what an Azure tool is and the different type of Azure tools. So in Azure, there is a plethora of tools that aid in getting tasks completed. The tools themselves and the types of tools are, for example, management and monitoring tools, pricing tools, migration tools, backing up tools, development tools, Azure tools for Visual Studio, storage tools, website tools, database tools, virtual machine tools, and media service tools. Each tool aids in a specific task as indicated by their respective names. For example, tools that are used for storage are, let me scroll up quickly. So storage. Okay, so tools that are used for storage, for example, are AZ Copy and Azure Storage Explorer, and they fall under the storage tools category. And others that are used for migration are found under the migration tool category, and so on and so forth. So 2 tools that can be used in a probable laboratory would include the Azure Portal and the Azure PowerShell, which falls under the management and monitoring tools. Azure Portal is extremely useful and was used heavily throughout this demo. As a user, we simply access the portal through the browser to connect to Azure and manage the Azure resources. The Azure Portal is the public web-based interface for management of the Azure platform. And this is designed for self-service tasks such as demonstrating the spinning of an instance in Azure, as we did in this lab. A large number of simple tasks can be completed in the Azure portal. However, the portal alone is not sufficient for deploying large tasks or automation tasks. This would need the help of another tool, the Azure PowerShell. PowerShell would allow us to automate complicated tasks in Azure. In contrary to the classic approach of using the browser and accessing Azure through a web interface, the PowerShell allows access through the terminal. Now that we have the tools addressed that we will be using, let's get into what the probable course laboratory would encompass using the Azure tools. In this theoretical lab, we will be focusing on deploying a Smart and Fire app using the Azure API for Fire, as they did here. So the goal of this theoretical lab would be to deploy a Fire sandbox in Azure, as can be seen throughout this guide. The Azure API for Fire team created and maintains a GitHub repository that contains samples of Smart and Fire applications. Present in the repository, as we will go to right here. So present in the repository is a patient dashboard, an Azure function to load patient-generated data from Cynthia, and templates for Smart and Fire applications. So this is everything that the repository contains. So basically, you create a Smart and Fire app, you connect to Azure, and you use data in the cloud infrastructure like that. So number one, the primary task of this lab would be to create a mobile application, Smart and Fire application, that would solve an existing patient problem. So this existing patient problem could be getting information from a diabetic monitoring machine or using a home-based monitoring tools. Example templates for Smart and Fire application can be found in the repository. The main goal of this lab would be to deploy this repository in a sandbox in R using PowerShell, which is a tool, and also deploying this script in Azure PowerShell. So basically getting a feel of Azure and how to deploy in different instances using a Smart and Fire application that is created by the student. And that is it. Thank you for your time.